There we all are. I think most of you are getting your videos on.
Excuse me, Miss Betterton. What's it called? Josh is having difficulties joining the class. Like it's not letting him.
I keep admitting him. I was just typing him a message.
Yeah. It's like it keeps crashing.
Why it won't let him in. Riley was on as well. Did she get back on? Josh was in the other class, Zion, and he could be using the other class link, which could be causing him problems. I sent him the new link for this class. He needs to just be sure he's got the correct one. That could be one of the problems.
You sent it through his email, right?
Yeah, I sent it through his email, and it should show up as well in Teams that he's in this class. I don't know if I deleted him from the first one, so I'll have to check that after class today. So he could be showing up in both of them. He just needs to be sure he's in the 202 section. That's the same thing with Riley too. If anybody knows Riley and is communicating with her, that could be what's going on with her.
Oh, all right. Beautiful.
Okay. So Josh, you're in now?
Yes, ma'am.
All right, good to go. Kicked myself out there for a moment. All right, just so that you know that we are recording, so that is also something I try to do for class. So in case that you miss, I post recordings. It does take a day usually for the recording to download and process before I can record it. But I do try to record class so that if you happen to be absent, then you can hear and see what we went over in class. I also try to post notes as well, and I try to get those out later in the day. So if you didn't see Monday's posting, I did get those postings out about notes from class. So if you were out from Monday and missed Monday, then you should be able to pick those notes up as well. So be looking for that information. If you happen to be absent, or if you missed Monday, you know to go to look for that so that you can get that information. You were asking about assignments. The only assignment that we've had so far has been the syllabus quiz. I'm a little behind the ball game in getting the assignments out, having students switch and add and drop classes. We've had to reorganize some things, but here's what to expect over the weekend. I should get assignment 1 out that will cover lesson 1 today. And then there'll be a small quiz, about a 20-question quiz that's pretty easy, that covers the concepts from lesson 1 that you'll take. Tomorrow I'll get out lesson 2 assignment, and then you'll have a quiz that will cover that. The due dates won't be tonight and tomorrow, but that information will be posted so that you'll have it. And then by Sunday, I will have lesson 3 information out, and it will have an assignment and a quiz that follows with it. So the procedure is that we have the lesson, then you have an assignment, you work through some problems, you do some review, you take the quiz along with that concept, and then we move on from there. We'll have a unit test on Wednesday, so we'll be reviewing in class on Tuesday. So the unit goes very quick. And as I said on Monday, these first 2 units are super quick. So it's going to go very, very fast pace. You're going to have to work very quickly through items and topics. So if you have questions, it's very important that you stay on top of things and you get in to see me at the library and Wednesdays very quickly if you're having difficulty. Okay? So I can give you a better idea of what to expect and what's going on.
Yes, ma'am.
All right. All right, so we'll go ahead and start with the lesson for today. As I said, be sure that you've taken care of the syllabus quiz. That's the one thing that should have been taken care of already, and you'll be getting the information about assignment 1 later today, and then we'll go from there. So just be sure that you're watching the news postings. Check once a day in Brightspace for the news postings. And if there's something very quickly that comes up, that's what I use the remind for, to let you know if there's been a quick change, so you have information. All right. All right. I'm going to switch screens now. Let me know if you can't see or hear something. Okay, can you see a blank sheet of paper?
Yes.
All right, good. We're on the right place then. Thank you. All right, lesson 3 covers Venn diagrams. And how they relate to sets. So the first thing that we want to look at is a definition for a Venn diagram. And how we would define a Venn diagram is just a picture to represent a set. So let's go through some examples of how we take a set and use the Venn diagram to show that it's a set. So we have set A, which has the elements 1, 2, and 3. And we're going to use a Venn diagram to represent that. So in its simplest form, the box represents the universal set. So if you remember from our past lessons, the universal set is the set that contains everything related to a particular situation. So the universal set for this particular situation has set A in it. We label the set, whether you label it the A inside or outside, doesn't matter a great deal. You just need to be sure that it's labeled. And then we put the elements, 1, 2, and 3, and they can be anywhere inside the set. There's no particular order that they have to be in. So a picture of this set in a Venn diagram. So this is the Venn diagram, this is the set, and so all a Venn diagram is a picture to represent a particular set. That is the basis of what a Venn diagram is. Now, let's do one with 2. So we have set A that has the elements X, Y, and Z. And we have set B that has the elements X, R, and S. So we still have the universal set. We have a circle to represent A. We generally draw our sets overlapping. So we have A and we have set B. The first thing that we do is we look at our elements in the 2 sets. Do they have any elements in common? And yes, they do. They both have the element X. So the position of that element is important. It has to go in the area where they overlap. So we have to place that X in that area, in that region. The other values for A can go anywhere outside of that overlapping region. And the other elements for B can go anywhere outside of that overlapping region. And that's how we'd represent the Venn diagram to show the sets A and B in the same universal set. Now, again, let's make it another step, a little more complicated, by looking at 3 sets. So let's start with the universal set, which has the values A, B, C, D, E, F, G, and H. And then we have set A, which has the values A, B, C, and D. We have set B, which has the values B, C, E, and F. And we have set C, which has the values F, A, B, and G. Okay, first we draw our universal set. Then we draw a circle for A, a circle for B, and then a circle for C. and label each of those. Now the question is where to start. And we want to start here in the middle. So we look at the three sets. Are there any elements that overlap with all three sets? That's the first thing that we look for. Is there an element that overlaps with all three sets?
So would it be B?
Yes, that's right. It would be B. If we're looking at those three sets, the B is what overlaps in all three. So that element B has to go in the very middle where all three of those circles overlap. If there was more than one element, all of those elements would have to go in that area or in that region where the three circles overlap. All right, let's look at two sets together, A and C. If we compare A and C, are there any other elements that set A and set C have in common?
A.
A. So I'm going to just mark through it so I can keep up with which elements I've dealt with. So the element A has to also go in the region where A and C overlap. Is there anything else with A and C that's in common? No. So let's look at A and B. What about A and B? Any elements with A and B that are overlapping?
C.
C. So I take that element C and I have to place it in the overlapping part with A and B. And finally, I have to look at which two sets? B and C. What do B and C have in common, if anything? Sometimes they don't have anything in common. So what does B and C have in common, if anything?
They have F.
They have F in common. So I'm going to take that element F and place it in the overlapping part for B and C. Now I can go back to A. Is there anything I haven't covered in A? The element D. So it goes out here in the open part for A. Is there any element in B that I haven't covered? The E. So it goes in the open area. For C, is there any element I haven't covered? The G. So it goes in the open area. And then we have to go check the universal set. Have we covered all the elements in the universal set? So we have the element A, we have the element B, we have the element C, we have the element D, we have the element E, we have the element F, we have the element G. But what do we not have? The H. So where is the H going to go? It's going to go outside the three circles somewhere in the universal set. We could put it here, we could put it here, but it has to go somewhere outside the three circles. It's an element that's in the universal set, but not in set A, B, or C. So again, a Venn diagram is a picture to represent sets. So if we only have the one set, that's pretty self-explanatory. The Venn diagram shows what is in the set, what's not in the set. When we have two sets, it's not quite as complicated, but then when we get into three sets, it gets a little more complicated to figure out where the elements need to go. And then, of course, we can't forget what's in the universal set that's not in the other sets. So that's the basic concept of Venn diagrams, a picture to represent a set. And we have to figure out what goes in which set, what does not go in the sets and is in the universal set. So that's the first step of Venn diagrams. Some fun facts. I'm sure you folks will think this is fun facts. All right, some fun facts. Venn diagrams is considered a relative new math invention. Unlike algebra, that's been around for hundreds and hundreds of years, since Aristotle time, Venn diagrams have not been around that long. Venn diagrams was invented by a person named John Venn. So one of you might become a famous mathematician and can invent something new about math. Everything's not ancient. And he lived from 1834 to 1923. So he lived within a relative close to our lifetime, within the last century. And he is the inventor of the concept of Venn diagrams. Now, a person from way back in the 1700s called Leonard Euler, actually pronounced Euler. It's spelled Euler, but it's pronounced Euler. So you pronounce it like Euler, but it's spelled E-U-L-E-R. He lived back in the 1700s. He actually contributed to the concepts of Venn diagrams as well. He didn't necessarily invent them completely, but he did contribute to the concepts. All right, that's the basics of Venn diagrams. And now we're going to move on to how we're going to utilize Venn diagrams a little bit more. Any questions so far? Anything anyone has?
Nope.
All right, good to go. One of the skills that you want to be able to do is you want to be able to shade Venn diagrams. And you use this shading to show or to illustrate the operations on sets. Now, if you remember from lesson 2, the operations are things like finding the complements, finding union, finding intersections, finding the difference. So these are the things that you want to be able to do in terms of shading with sets. Now we're going to start with some really easy examples. And the thing about this is it looks easy at first, and it is. And then we start getting a little mixed up and a little confused. And the thing about it is you have to practice. You have to redraw them. Drawing them one time doesn't always help you to get the concept. Sometimes you're going to have to go back and just practice redrawing what those items are. So even though we may do this in our notes, you may have to actually go back and redraw these for it to make sense to you. So our first example is to draw the shading for a complement. Now, tell me, what does it mean to be an A complement? What would that mean in words? Who can tell me, what does A complement mean? Anyone? The complement of something means what's not in it, right? What's not in that set. So if we have the universal set and we have set A in it, how would I shade to show a complement? I would shade everything that is outside that set. Now, sometimes it's helpful as we're doing the shading is to use different colors. So if you have access to some different colors very easily, I would get some different colors. A blue pen, a black pen, a pencil would be helpful. If you have access to a highlighter, that's going to be helpful. So if you can get those materials out very quickly, that would be helpful for what we're going to do next. Technically, you're supposed to shade all of this in, but as we're working with Venn diagrams, sometimes it's not feasible to actually shade this in. So using a pattern for shading is very sufficient to do for shading. All right, another example. Another pretty easy problem is to show A union B. So again, we have the universal. So we have set A, and we have set B, and we label them. Again, whether you label inside or outside doesn't necessarily matter. And if I'm showing A union B, that means that I combine everything in A with everything in B. So that would be the shading to show A union B. A next pretty common one is A intersect B. So again, we have the universal set. We have set A. We have set B. And what does intersection mean?
They're joined together.
Yes. Where are they in common? What's overlapping? So that shading would be, where are they joined together? Where are they overlapping? So we would just be shading that middle part. Well, let's do one with three sets. We still have the universal set. Set A, set B, set C. So if we were doing A intersect B, that would be this region. And then if we take that answer and intersect it with C, that gives us that region. So overall, the answer would be just this little part. For our final answer.
Professor Betterton, can you explain that again?
Sure. All right. If we look at the first two, A union B, we know that that shading is where A and B overlap. And then we take that answer where they shade and look at where does it overlap with C. So when C comes up here and overlaps with that, that's just in that area where the C also overlaps with it. So that's the red part. So what is the final answer? And that's where I've highlighted it in the yellow. The final answer of all of those together is just that little segment. That's where all three of them end up. Does that make better sense? Okay. So when we start working with the three sets, it does get a little more complicated. We have to look at it a little differently. Now, we've looked at it from the perspective of, here's the problem, create the shading. But you want to also be able to do this in reverse. In other words, you have the shading and you want to figure out, what does the shading represent? So we have the universal set. We have set A. And we have set B. And this is the shading that's shown. So what problem does that represent? So we have to kind of turn our brain around and work backwards. Well, this region is not shaded. What is that region? That's B, okay? If it's not shaded, that means it must be a complement, maybe. Does it appear to be a complement? Could that be B complement? Does that work? So what you do, or a way to do that is, okay, come over here to the side and quickly sketch. Okay, if I did B complement, would I get the same results? If you're unsure, that's a way to match it up. If I shaded B complement, do I get the same results as what's showing? Yes, I do. So that kind of helps, gives us a way to figure out if that is correct. So if you can't look at it and tell, is that the problem? Then, okay, if that's what you think it may be, shade it and see if it matches. So that's a way to approach that kind of problem. Now, we also need to think about, since the problems are going to get more complicated, what is the technique to use for these more complicated problems? And this is where the extra colors and the highlighter can come into play. So we want to show the shading for A prime union B. We want to show the shading for A prime union B. Now, some people like to do it in steps. So they like to draw one drawing for each part. Some people like to draw it one over top of the other. Some people can visualize this problem right off the bat and know what the answer is and have no problems doing it. And I can't answer that for you. I can't answer which is going to work for you. You're going to have to practice problems in each technique and figure out what works for you. If you're a person who's pretty artistic and pretty visual, you might be able to draw this right off the bat and have no problems, and that's great. If you're a person who's not very visual, you might have to draw it step by step, and that's okay. Don't feel bad because you have to draw it step by step. Take the time to do that because it helps you come up with the answer. Don't think that you're doing it wrong because you do it step by step. All right, so I'm going to show you the techniques. It's up to you to whether you practice them. Okay, so if we do it step by step, we're going to draw this step first. So step 1 is to draw A prime. So drawing A prime means that I would draw everything that's not in A. Now, even if I was just doing one drawing, that would still be the first step of that one drawing, is to draw A prime first. So it's still a kind of a step-by-step process. Some people just like to do it in separate drawings. Some people like to do that step-by-step on the same drawing. So this is with separate drawings. This one is with on the same drawing. Okay, step 2 is to draw B and to look at that component. So if I was drawing B, that means that I would have this part. If I was doing that on the same drawing, I still would do the same thing. I would draw B. The third step is to do the operation. What is the problem asking us to do? The problem is asking us to combine A complement with B. Sometimes you'll hear that called A prime versus complement. So we want to combine these two sets together into one big set. So that means that this will be the only thing that's really different than the A prime is to add this little part in the middle when we joined the two sets together. And sometimes it's also helpful to highlight it because it helps us to visualize that a little better. Or to see that graph better. But the highlight is especially important if you're drawing it one on top of the other. The highlight helps us see what the final answer is. Okay, if I'm doing the union, then my final answer is the part that's highlighted. So whether you draw it step by step, or whether you draw it step by step, one on top of the other graph, you have to figure out what works for you. And some of you are going to know this is the answer right off the bat. But you're going to have to practice to figure out what works for you. It's going to take more than one problem, more than one try to figure out what works for you. We're going to try some additional problems here because it's going to take more than one problem to figure out how to do this. So let's try another problem. Let's just do another variation. Instead of union, let's do A complement intersect B. So first we do a complement.
Can you move the picture a little bit?
Sorry.
Thank you.
So A complement would be everything outside of A. If I was doing it on one figure, that's still how I would start. Wow, not focusing very well. Step 2 is to look at B, just like we did before. So on my one figure to look at B, and then step 3 is to look at the intersection. And what does intersection mean? Intersection means to look at what they have in common. So this region is where they overlap. And that would be the intersection of A complement with B. Again, if I wanted to shade that with a highlighter just so it would stand out more, I can do that. On my one graph, using the highlighter is essential there to help me see the final answer. On an intersection, we can see where the double parts are, but it kind of helps bring out the part where they overlap if we use the highlighter with it.
Would we highlight the middle too?
You do not highlight that little middle part because there is no overlapping there. You see, it's only the B part in the middle part. It is not overlapping with not A there. So intersection has to overlap. It has to have both of them. So it's like a crescent moon. It curves around outside of A and then the rest of B. Okay, let's do one with 3. So we have A union B intersect C prime. Okay, if I'm going to do A for my first step, that would be everything in A. If you're doing the separate drawings for each, if I'm doing one drawing, still the same. Everything that's in A is how I start. Step 2. Is B. So I am including everything that's in B. It's probably best if I use a different direction. Actually, I'm going to use double direction on B. So if I wanted to do the union of A and B, that would be to combine those two together. So I can see that where I have my one drawing all together. But if I'm doing separate drawings, I kind of have to do that as a separate step. So there's my union part. So step 4 would be C complement. So C complement would be everything that's not in C. Everything that's not in C. Now I add that not in C to my one drawing. And the last step is to take this union, that answer, with the complement of C, and to look at the intersection. So where does this union intersect with the complement? So you'll notice it is above the C and in A and B. And in our one drawing, again, the highlighter will help to spell that out. Our final result are all of these regions there. Oh, I shaded too much. This area should not be highlighted. I'll put that in red. That area should not be highlighted. I shaded too much with the highlighter. Okay, so that was a little more complicated. Took a few more steps, a little more involved. It's going to take practice, folks. I know for some of you, the visual part is more difficult, but it's just going to take some practice problems to get a hold of that. All right, let's take a break here, okay? We've been at this for a while. So at a 10-minute break, please. So we should be back at 12, okay?